All right, everybody, let's take a look at lesson number 4's homework assignment. So in lesson number 4, we learned how to convert from radians to degrees and from degrees to radians, an important skill in trigonometry. Most of the time when we have radian measurements, we do normally want to change it to degrees, but the radian measurements are important. You'll see that when you start graphing. So there was something in class that I wrote down on the board, I'm sure, and we're going to use it here in the lesson. So on the reference sheet, it says 1 degree is equal to pi over 180, and it says 1 radian is equal to 180 over pi. These are our ratios, or our converting ratios that we're going to use. So depending on what you're given is going to depend on which ratio to use. So the first question gives us 3 different degree measurements, so we're going to use that first ratio. So 45 degrees, well, if each degree is represented of pi over 180, I'm going to take 45 and multiply it by pi over 180. That just converted to radians. Now I want to reduce that, because what I have here is a fraction of 45 pi over 180. So if I reduce that, 45 goes into 180 4 times, so this becomes just pi over 4. So 45 and pi over 4 are the same thing. They're the same angle. (120) we're going to do the same conversion for. So this is really 120 pi over 180. 120 and 180 have a common value of 60, so if I divide each one by 60, I'm going to get 2 pi over 3. Just reducing fractions, just leave the pi in there. 450, so we're going to do 450 times pi over 180. So again, we're going to get 450 pi divided by 180. And we can go through and reduce that. The value that's common there is 90. So that's going to become 5 pi over 2. If you're not good with reducing fraction, just type the fraction in your calculator without the pi. Now, if you do 450 divided by 180 in your calculator, it's going to tell you 2.5. Hit math, enter, enter, and it tells you 5 over 2. So it reduces the fraction for you. All right, let's move on to radians. So for radians, we're going to take whatever the radian measurement is, so negative 5/6 pi, and we're going to multiply by 180 over pi. If you do this correctly, the pi's should cancel away. Usually that happens when converting to degrees. Not always, but usually. And it just becomes, can you multiply this out? Type it in your calculator, right? So if you type in negative 5/6 times 180, you're going to get negative 150 degrees. Three pi over 2, so we're going to say 3 pi over 2. Multiply that again by 180 over pi. The pi should cancel. Type that in your calculator, and you're going to get 270 degrees. 13 pi over 20, so we'll take our 13 pi over 20 and multiply that by 180 over pi. It's just a conversion, that's all we're doing. We're canceling out the pi's, and then see whatever that comes out to be. I need my calculator for that one. So if I do 13 over 20 and multiply that by 180, I get 117 degrees. Number 3 says to explain how radian measurement is related to the radius of a circle, draw and label an appropriate diagram. So what we learned in class is if you have a circle, the radius of that circle has a relationship between however big that radius was that open, that degree value, and however long it took to get around the circumference of that circle. We call that the arc length, and we'll label that S. So the relationship here is that the angle, or the radian measurement, is in a relationship with the radius and arc length. The relationship is the angle is equal to the radius divided by the arc length. And there were a couple of questions in class that we used that relationship for. Okay. So radian measurement is really just another way of measuring an angle, and instead of measuring it in degrees, we're saying, well, how many radiuses would fit around this arc length? That's all we're doing here. Okay. Hopefully that made sense, and I will see you all soon.